Yo, 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 Algebrainiacs! Welcome to the Johnson-Kendra Video Hour!
But it's not ours.
Oh man, I wish it was today! This is fun stuff. Okay, you learned back in the day about direct variation, so let's review a little bit about that.
Before we get into that, inverse.
Right, inverse is where we're headed, but direct has to be a little review first. So in direct variation, the equation has the form y equals kx. If you were to solve for k, you can just take y and divide it by x.
This kind of looks like a slope to me.
It does. Y equals mx is kind of the same deal. So if you can remember y equals mx plus b, you can kind of remember direct variation too.
Also, the b has to be 0.
Right.
Okay.
And the k, if you know how to spell, stands for constant. But I don't know how to spell, but that's how I remember. The K stands for constant.
Constant of variation.
Right.
All right, here's an example of direct variation. Mrs. Kendra makes $30 an hour.
Woo!
Look at her.
Oh my, where did you get that picture?
That's your high school graduation photo.
High school. Oh my gosh. Did I really go to high school?
And you learned algebra too.
I did.
Mrs. Kendra makes $30 an hour tutoring students for the ACT. The money she makes varies directly with the number of hours that she tutors. So this is a direct variation situation. So first we should identify what is like our y and what is like our x.
Right.
So you're making some money and you're working some different hours. So those are our two variables.
So money and hours.
So what's in control?
Well, how many hours I'm working will determine how much money I make.
So therefore, the number of hours is like your x because that is control or that is your independent variable, and then the money that you make is like your y.
Right.
All right, so how much money do you make? You make $30 an hour.
Uh-huh.
That's good money.
That's good money. It's worth it though because kids do well on their ACT.
So what's an equation that would represent that situation? Y equals?
KX.
So 30x. $30 times the number of hours that she works equals the money she makes.
Right, and the 30 is constant, that doesn't change, so that's kind of your clue that that's your K.
Okay, now we're just trying to develop some data points. So for instance, if you work 1 hour, how much money do you make?
$30.
And that's because we're multiplying, this is like our x, we're going in and we're multiplying 1 times 30, she said $30. What if you work 2 hours?
Ooh, $60.
And how about 3 hours?
$90.
Here's a question, if you don't work any hours,
No money.
no monies. Okay, so those are just some examples of data points. And then lastly, we are going to sketch that graph. Again, this is major review from Algebra 1 direct variation stuff. So I'm just going to make a very simple graph according to the data points that we use. We said x was hours tutoring, and therefore this is the monies.
Show me the money.
I'm going to
So
change.
you're changing the scale to fit your points. That's nice.
Yeah.
They don't all have to be ones and ones, twos and twos.
Yep. So one of our data points was 130. Another one was 260, 390, and 0, 0. What does that look like?
That's a pretty straight line.
And that makes sense, just like we said, this is very similar to y equals mx plus b. It just so happens that the b, or the y-intercept, is 0, has a constant rate of increase. Constant.
Constant, yes. Kind of like Kendro.
All right.
With K.
Okay, let's point out some other trends here. So the takeaway from direct variation, it says the ratio of the corresponding x and y values is constant for direct variation. They spelled that down there.
So y equals kx.
So k, our constant for your situation, is taking all of the y values and dividing them by the x's. So for instance, she made $30 in 1 hour. She made $60 in 2 hours. She made $90 in 3 hours, and all of those things equal 30.
Got it.
So dividing all of the y's by the x's. That's direct.
Got it.
And if you look back to our original equation, that makes sense. That's just manipulating that original equation.
So you could divide by x both sides to solve for the k.
Yep.
Got it.
So that's direct. So now we're going to switch gears.
inverse. So the other one was y equals k times x. This one is y equals k over x.
Yep, and that's what we've got in the box there.
There. So to find the k, this time we could multiply the two.
Correct.
Got it.
So what do you think our takeaway is on this one? Not the ratio of
But the product.
product. So the product of the corresponding x and y values is constant for inverse variation.
Ah.
So multiply them together for inverse to get your constant, divide them. Yeah, and you can just look at the original equations and manipulate those.
Right.
Just like she said on the last one, we divide. Here you'd have to multiply.
Right.
Yep.
So these are the two you want to remember over on the left.
Yep, direct is the top one, and inverse is the bottom.
All right.
Okay, so here are some examples similar to what you're going to see out of the textbook. It says, is the relationship between the variables a direct variation? It's supposed to say and. Inverse variation, or neither.
Oh.
If it's direct or inverse, we are supposed to write the equation, and that means that we'll need to know the k values. So just have a data set here.
Okay, so we're going to either multiply them together or divide them to decide which one has the same answer the whole time.
That is true.
And then we'll be able to tell.
Yep. So really up to you how you want to organize your stuff. I'm just going to extend that table there. So do an x times y column. That would create constants if we have an inverse variation. And then we also need to check for direct variation, which is y divided by x. All right, so should we do all the x times y's first?
Sure.
So if we do 0.2 times 8, we get 1.6.
Okay.
If we do 0.5 times 20, we get 10. If we do 1 times 40, I hope you know that one. And then I bet you know the next one too, that's 90.
So
Those are not
all different.
right, so that tells us that this is not an inverse variation because those are not constant with a k. Okay,
So we'll see if it's direct now.
so now we're going to go through and divide the y's by the x's. I do want to tell you that you could divide x by y, but that's kind of a bad habit because anytime we want to find k values, it's y divided by x. So just get in the habit of doing y divided by x, just like slope is rise over run, y over x.
Yep.
All right, so 8 divided by 0.2 would give us 40. 20 divided by 0.5 would give us 40.
Ooh, I got
And
a pattern
40.
happening here.
And 40. And 40. Oh, that's too many 40s. Okay, so we got to answer the questions. They wanted us to answer, is it direct variation, inverse variation, or neither?
Looks like direct to me because
Okay.
it worked when we divided to get all the same answer.
So we'll have to say those words. It's direct variation.
I'm going to abbreviate.
That's
okay?
fine. You know I'm fine with that. In addition, we need to write the equation. So you have actually done all the work already. You found the k value. So what does direct variation look like again?
Y equals kx.
So therefore, we are going to say y equals.
40.
Okay, very good.
Thank you.
Let's do the next one. Similar.
Hey.
All right, so this time I'm going to do what she did on the last one, and I'm going to check for inverse variation and direct variation. To check for inverse, we multiply x and y. To check for direct, we divide.
All right, so 0.2 times 40 is 8.
Okay.
0.5 times 16 is 8.
Oh, I know that's 8.
And 2 times 4 is 8. So I don't think
Yeah, I don't think we need
that.
to do this either. So we already found that these are constants. Therefore, this is our k value in the inverse variation situation. So I'm going to say that first. I'm going to abbreviate.
All right, I'll let you do that.
And remember, the equation for that is k over x. So therefore, we will say 8 over x.
Cool. That doesn't seem too bad.
No.
All right, one more here.
So going through and
Same deal.
checking for first products and then ratios.
So y times x, the top one is 20.
20.
And 14.4, 20,
It's not oh, we do get a 20
and
though.
15. So
Okay,
it's
not
definitely
constant.
that. Okay. Y divided by x, first one's 80.
Okay.
Then 10, 5,
Yeah,
2.4.
this is definitely not constant either. So this does not represent a direct variation. It does not represent an inverse variation. So the only answer that we can say here is neither.
So the graph is kind of probably curvy, like all over the place.
Yeah.
It's not a smooth curve or a straight line.
Yep. Next, this is another type of problem. So this time they're telling us that x and y vary inversely.
Inversely, so that means y equals k over x.
Okay, so we can kind of forget about direct variation for a second.
Okay. So it says, suppose that x and y vary inversely, write a function that models each. So basically, when it says write a function, that means find k.
Okay.
All right, so
K.
all right, here we go. So plugging into this equation here, I have a y, so I'm going to put 12, and I don't know k, and I have an x, which is 4. So if you're trying to solve for k, think of this as a ratio, both sides as a proportion, and you're going to cross multiply.
Or you could just multiply by 4, right?
Yeah, that works too. So 12 times 4 is 48.
That's k.
And 1 times k is k, so k is 48. So we have to rewrite it. You have to write it over again using our new k. So y equals 48 over x.
Okay.
So there's our model.
I didn't cover my steps over here. So
Oh.
that's okay. That's just going to summarize what we did there.
Those are the steps. Write y equals k over x, substitute value, solve for k, and rewrite it.
All right, here's another one.
Okay, so again,
you said that I need to set up the inverse function and then substitute. So -7 this time equals k over 8.
right.
And to solve that, I would multiply by 8 on both sides, or do a proportion would be fine. We'll get -56, that's our k value. But we're not done because we need the function. Y equals -56 over x.
Good job.
All right, part 2 though does say graph the functions from above and find y when x equals 10. So for the graphing, we're just going to use the table of values and sketch the graph. You can help yourself out by choosing some x values that are factors of the k. Yeah, let's do number 1 for time's sake. Let's skip number 2. So we're just going to do one example for you.
So there's our formula.
Just pick like easy
Okay,
stuff.
so I'm going to pick
Factors are 1,
1, 2,
even 3. That's
3.
probably fine. You could
Okay.
divide those by negatives. You want to do -1, -2, -3?
all right. That's
Can't
gonna,
divide by 0.
right. That would be the world exploding.
Oh,
That's not fun.
we don't want that. Okay, so if we plug in 1, 48 divided by 1 is 48. 48 divided by 2 is 24. Used too fast for me. 16. Now they're just negatives. -48. All right.
Okay, so my x values are small, so I'm just going to count by ones. Say 1 here, -1 there, but my y values are big, so I'm going to count by
Maybe by 8s or something.
8s or
Even bigger, maybe.
10s. Let's count by 10s.
Okay.
Then I only need 5.
Now, if you're going to change the scale, get us some labels on there.
Yeah.
Yeah.
Okay, almost. So there's -10. And I'll do 20, 30, 40, 50. All right, so 148 is approximately there. 224 is approximately there. 316 is about there.
All right.
Let's do the other ones. -1, -48 is down here. -2, -24 is here. 316 is about here.
Well, that looks like nothing we've seen before.
Yeah. So, if you want, you can do more points, but in fact, let's do one more point, just to kind of, let's do 8, something a little bit bigger. So if I go out to 8, divide 48 by 8, I get 6 and -6. So 3, 4, 5, 6, 7, 8. And 6 is about here.
I'm gonna get in here.
Yeah, I'm going to get out of
We
this.
get the idea.
All right, we get the idea. So what this really turns out to be is 2 separate little curves.
Now remember, we would have that negative.
Yeah. And it's not going to cross over the axes.
Oh, because this is called an
Asymptote.
Oh, yeah.
Woo.
All right, so you'll notice we did a pretty general sketch here. We changed the scale and things like that. That's fine. That's just a general idea at this point.
Right.
Okay. Oh, we
Alright.
did have one other thing to do. We graphed the function, so we got that part done. We also had to find the y value when x equals 10. So that's pretty simple. We're given an equation. If you had this on the graphing calculator or something like that, you could use your trace button to find that, or we could just plug it in.
Oh,
So if we do that, we're going to get 4.8 for this problem.
okay.
And that should match up. This is 8 on our graph. If we were to continue a couple more, that would make sense, I think.
But that's a little lower.
Yeah.
Okay, good. All right, last one. After a storm, Interact volunteers remove debris from the yards. The table shows the time t in minutes it takes a group of n students to remove from an average size yard.
So all of the data is for an average sized yard. The first
I have
problem.
an average size yard. Do you?
Yeah, I would say average.
They didn't clean my yard. Did they clean yours?
They did not.
Oh, we're gonna have to
Correct.
get on that.
I'm in Fruitport though.
Oh, sorry.
Maybe Fruitport schools will come help me out.
Maybe.
All right, what function models the time needed to clear debris relative to the number of students working? So we're looking for a function that tells us if we have however many students, how long is it going to take?
All right, so
Identify domain and range. So again, what's in control? Number of people we have controls how long it takes.
probably.
Okay,
Because the fewer people, then you decide how long it takes.
I think that makes sense. So we're going to call our n like our x, that's our domain values, and therefore time it takes, or our t is like our y.
Okay.
Find
So
our
do we
k.
have to decide if this is direct or indirect?
I think we
Or
should
inverse?
take a look at that. Why don't we try our inverse first, which would be k equals,
Or
k equals x times y, because they have a common product.
that's a little easier to multiply.
Yeah.
So we get 225 here. 75 times 3 is also 225. Oh, look at there. So we know.
That's
It's-
actually 2. Close enough,
Oh, close enough. This is okay.
because that's just a general experiment here.
Right. It's not. It can't be always exact when you're talking real life.
Yep. So we just took a data sample there. I think that tells us pretty clearly that this is inverse variation.
Mm-hmm.
So if we did our multiplication correct here, we have now found the k value. The k is equal to 225. And pretty quickly then we can write the equation. It's supposed to be k divided by x. And, we could check some answers here. Say 225 divided by the number of students.
Yeah. So we're not graphing here, but they do want to know.
So, pardon me. So now we're going to use it.
How many students should there be to clear debris in at
At
most 25 minutes? So minutes was our y, so we want to put,
Okay, so since they gave us minutes, you're saying put that for y.
right, so y equals,
Y equals k over x. And in our situation, that's y equals 225 over x. So 25 equals. I was going to write 225 equals 225 over x. All right, now.
x is on the bottom.
Yeah, so some of us, I think, are tempted by dividing by 225, but that won't give us x. That would give us 1 over x.
Well, make it a proportion maybe,
Okay.
and then just cross multiply.
Ooh, I like that. 25x, because that's 25 times x here, and then 1 times 225 is 225, and then we can just divide, because then our
No.
variable is not in the bottom.
Right. I tell my SAT students a shortcut here. You want to know it?
Yes.
Once you put it in that proportion,
Change
change
my color.
25 over 1 equals 225 over x. I tell them if there's a bridge here to cross, that's that equal sign is a bridge, then you can swap. You can switch these two and just get x equals 225 over 25. Isn't that slick?
Yeah, I like that.
And then you can figure it out again.
There's a
9.
bridge to cross.
There's a bridge to cross. You can swap numbers.
All right, that was a long one.
Whew, sorry about that. It was almost an hour. It's 1/3 of an hour. But next time we'll be a little nicer. All right, ta-ta for now.